Hello everyone, let's wait a few more minutes and then we'll start. Okay, let's start. Hello everyone, welcome to today's session, and today we're going to continue talking about object-oriented programming in Java, and today we'll also start covering practical tasks. I just shared with you in this, but so you can check them. And these are the tasks we'll use today, we'll go through today. And maybe on Monday as well. Let's see how it goes from the time perspective. And so yeah, that's what we will have, what we'll do today. Last time, as you remember, we started checking some properties of instance and static attributes. When we talk about the computers, you remember that we had non-static attributes and static attributes, and the difference was that they said that non-static attributes belong to object and to the corresponding object, so we can create multiple objects, and all of them will have different. Each of them will have different attributes with different values, with different pointer to the memory, and so they are independent from each other directly. I mean, of course, you can create logic and create the dependencies in between them, but by default, with no additional logic, all these attributes and different objects are independent from each other. And then we have static attributes. Static attributes belong to the class, not to the object, so it means that for all the classes, for all the instances of the objects, if we use static attributes, basically static attributes will be the same for all the objects of the class. So, and in fact, even more, as you remember, when we type something like object and static attributes, then we get the warning. So this model, and we get something like meaningful, and we get warning. And as you remember, that's because object does not have this attribute. This attribute does not belong to the object. It belongs to the whole class, and that's why we get this warning. Java recommends us to change the syntax to this way. That we access from the computer class directly, and we access the model attribute. So these are the main differences between static and non-static attributes. All right, so that what we talked about attributes. Then we also talked about access modifiers. Again, as I said, we usually use private, and I mentioned why we mostly use private attributes. That's because we want to control the inputs, control the input and output as well, so to not be able to just randomly access all the variables from all the parts of logic. I mean, if you have tens of classes, like if they're located in different packages, so we should restrict accessing them from different classes and different packages as well, and that's why we use private access modifiers for the class to make the control more flexible, more strict, and from this perspective also more flexible and more correct. If you try to modify the attribute, of course, it's better than we have some checks, like setter methods. We'll talk about them today, getter and setter methods, so-called, and also some additional methods which can actually change or get the values of the private attributes. All right, so that was what we are talking about. Private members of the class, and also the last thing we talked about was constructors. So as you remember, the meaning of constructor is basically comes from the name constructor. We want to construct the object, and the constructor method, that's basically the method. Maybe it's not exactly the method by default definition, but the properties of constructors are almost the same as for the methods. For all the other methods, we have input parameter. We can have input parameters. We can have no input parameters, and we have the logic inside. The only thing is comparing to the methods that we do not have the returning type, and that's because basically we construct the object, and in fact the class will, if you think about it in theory, the class will always be the returning type of the constructor, because, as you remember, to call the constructor we call new. We use new keyword. When we use new keyword, we provide the class name, and inside the brackets we can pass the parameters to constructor, and at the end, as the result of this operation, we will get the object. So as I mentioned, constructors can have the parameters, can have no parameters, and by default each class does have the constructor. But by default, if you don't write any logic, then by default the constructor is just empty method without any parameters and without any logic inside. Basically, maybe the question may be, why do we have these constructors in the empty constructors? We'll talk about it. That's basically because we have the inheritance, and we'll talk about the inheritance today as well. Basically, all the classes comes from the object class, and they inherit the constructors, empty constructors with no logic. But we'll talk about inheritance a little bit later. For the constructors, that's the main information. Also, I mentioned last time about the method overriding. We did not talk about the method overriding in general, overloading. Not overriding, overloading in general. But we touched this topic a little bit for the constructors, and the idea is that we can have constructors with we can have multiple constructors with multiple we can call it signature, or method signature. So for this method, the signature is for this constructor, the signature is basically these parameters, and we can have multiple constructors. But with different parameters. So, like in this case, we have such constructor. Then we can also have a constructor without one of the parameters. For example, we can have some shorter constructor. We can have a constructor without the parameters. It's also possible, but the idea is that we can have multiple constructors in the same class with different parameters. But that's more about method overriding. We will talk about overloading. We'll talk about it. And of course, that's also a little bit about method overriding. But that will be the next topic for us today. Okay, so that's it from the previous lecture. I'll also mention about this keyword, but we'll talk about it today as well. So right now let's move on to the presentation, and today we're going to start with the static and instance methods. So as you remember last time, as I just said, we talked about instance and static attributes. Today we're going to do the same, but with about methods. Basically, in fact, the properties for the methods are almost basically the concept of the methods. If we talk about instance and static, are absolutely the same as for the attributes. For the attributes, instance attributes belong to the objects, and static attributes belong to the classes. The same is here. Instance methods used for the class, for the objects, and static methods used for the classes. So that basically the usage is almost the same. But of course, since we have methods, we have some additional features compared to the attributes like returning type or no returning type, and the logic we can write inside the methods. So that's so from this point of view, we have some additions when we talk about the methods. But basically, all the things we talked about, the attributes, instance and static attributes, can be applied to the methods as well. So yeah, what are the types the methods can be? So the instance method, and we can call it using the object. As you remember last time, we had such method, this one, and display attributes. And we create the object, and then from the object we call the corresponding instance method. If we call it from different class, remember that the method should be public, mostly public or protected. But yeah, no, let's not talk about protected at the moment. Usually, normally should be public if we want to call from different class. The accessing to the attributes and to the methods are the rules for the accessing are the same. You have to talk about private and public and protected attributes or methods. The accessing is the same. So we can call instance methods after the object is created, as you know. So we cannot call, if we try to even more, we won't be able to compile the logic if we try to call the method before the object is created. That makes sense, because if we don't have the object, we actually try to call from so-called null reference. It actually means that it has no reference, and we will have but mostly you won't be able to compile the logic, but if you create the logic in the way that you are able to compile the logic, but the instance is not created, you will have null pointer exception. I guess in Java, I think that's null pointer exception. I guess so. Null pointer exception. That's basically the exception which says you that you try to access empty reference, and you will have the error exception. You won't be able to work with your object, because actually the object is not created. If the object is not created, you cannot call the methods, and also you cannot access the attributes as well. And that's also comparing to the static methods. We don't, as we can see here, we don't need to create the object to call the static method. Just directly from the class, we call the static method, and and the method does its own stuff. So we usually call it using the title of the class, and that's if we are inside the class, we can skip calling using the class, but as I said, I recommend to use the class name always, despite if you are regardless if you are inside the class or outside the class. If you use the class key, the name of the class, and then access the method for the class, that's more readable for the developers. Because if you have a lot of classes, a lot of lines of the code, then of course if developer quickly goes through the logic, then if developers reads the class name and accessing, then it's better to it's easier to read this code and understand this code. Yeah, so it can be coded in the title of the class, and also it is if the math logic is convinced without creating an object. Yeah, in some cases it's also possible to interact with the objects from the class, but that's not a special case, but just one of the cases when you can work with the objects. And yeah, so since we just start talking about such case, when I remember last time I mentioned, okay, I will not go deep here, but I'll quickly mention as you remember last time we had I mentioned such small case, like if we constructors by default are public, but I mentioned that we can also define the constructor as private. That's also private or protected, that's also possible. But what will happen in this case? In this case, you won't be able to just create the object from outside the class. And if you have private constructor, you are not able to call the create the object from outside the class. And basically, the question may be: so if we are not able to create the object outside the class, how can we do it? In some cases, there is such need. Yeah, again, as I said, I will not go deep here, but using the schema maybe in the following way: we define the constructor as private, and then we have a static method in this class which is public, and then using the static method, we actually can create the object, which and the static method will return as the object. So again, we have the private method. Actually, we have the class, which is some class from where we call the method. Then we want to create when we want to use the object of like for example computer class. Then inside, as for example, inside the computer class, we define one constructor which is private. In this case, we're not able to directly create the object outside computer class. But if we have static method inside this class, there can be the logic which returns as the object. So we just call the static method, and inside the static method the object is created and returned to the different class. Okay, maybe just as I already mentioned, let's quickly create it. So maybe just I will call the class private constructor just to easily distinguish it. So let's have the class. Just name it class. So private constructor. It's for you to understand. Then we define the private constructor. So in this case, I cannot create the object of this class because the constructor is defined as private. So, but what can be done here, and what is usually done in these cases, we define the public static method which returns us the reference type of this class, and this method, the name of this method usually is getInstance or constructor, something like that. It depends on the scenario. And in this method I can create the object, so I will add a comment. Not maybe down here. Constructor and as private. So yeah, we cannot do it this way, but we can do it this way. So as you can see, the class is not private, the class is usable, and I actually the method getInstance, and we will have the object created. Why this case is needed? This case may be needed if we have some restricting access to the creation of the object. So I will, again, at the moment I will not go deep in the scenarios, but in some libraries, and we'll work with some libraries, we will see that to get the instance we use the static methods. Again, there are some reasons for all these cases. Usually, again, the reason is that there are some restricting accesses to the constructors, so just to not be able to directly create the instance of the object everywhere. So that, I mean, just the same as for the private methods and same as for the private attributes. For the objects, there can also be restricted access. So yeah, and using getInstance static method, we can get the object. But yeah, in some libraries, in some classes, you will find that it is done this way. Yeah. All right. Let's move on. And there's one more thing about private and protected attributes, and what we usually use is so-called get and set methods, also called getters and setters. Yeah, basically the idea is that the data usually are private, and it is recommended that also the fields need to be private. That's true, and I think I mentioned once that so if we just think about what kind of access modifier must be applied to the field, to the attribute, then by default and most usual case is that we define it as private. We define it as private, and as you know, that's because we can have the restricted access to the variable, and just even more if you don't. I mean, you write the code, you create some logic, some scenario, you work on some scenario, then you create actually the class, you create the variable, and you define the variable as so if you don't have some specific reasons, you should define it as private, but just as an example, you work on some scenario, and you just think that, oh, I just don't need this attribute to be created as private, because just why, if I will just access it from all the different classes, I don't need to have some restrictions, and so on and so on. So this approach is not so good, because basically, usually when you write the code, when you create the classes, your code is most likely to be reused, or it is possible at least that your code will be reused in different scenarios in future. So that's why private attributes and if we accessing them using getters and setters is more stable option, because again, even at the moment, if you don't have any control, then it is still possible that in future such options will be needed, and in case your logic is used in lots of places, then it will actually be practically impossible to maintain this code, to just do some adjustments to the attributes, to the logic, if you declare these attributes as public and access them publicly. Because again, maybe I will also quickly code. So you have your attributes, you have the class, then you have the attributes somewhere inside. One attribute, another attribute, and so on. So there are some attributes inside the class. And so imagine if you declare them as public, then you have one place, you have another place, you have another place, and so on. So you have many different places from where you access these attributes in some way, some different way. So you do the logic with these attributes and so on. Then, so time passes, there are even more places where this logic is used, and at one moment you just get the requirement that some restrictions may be needed to access or to override these attributes. So what you should in this case, what you need to do if you don't use the private access modifier and just use public, then you need to check out all these codes when you used this attribute. So it's just imagine that all these places must be checked. So that's if your logic is used in hundreds of places, for example, that would be almost impossible to check all these places. But if you define these attributes as private, then you just need to check the methods inside this class and do some adjustments. And basically in this case, to access these attributes, we usually use so-called getters and setters. And maybe let's create the class. Getters and setters. So I'll just use this class to show this option. One more thing. When you create the class in the file in Java, you can go right click. Then there's source, and under the source you can generate getters and setters. Maybe just one quick example. If I have private attribute, this method was the type of private attribute, then you can just let's create two attributes. And so if you click on the class name, you click on source, you click on generate getters and setters, you will have the options to select the attributes to which you want to generate getters and setters, and after that the getters and setters will be generated. But okay, maybe let's quickly quickly manually go through what getters and setters are. Basically, you can do we can write all these methods manually, but you can also generate them. And as example, I will create the class person. Okay, maybe not person, that will be employee. And so then we have let's use the private attributes. The name, the surname, and just more, that will be age. So yeah, so now we have these attributes defined as private, and basically the most common option how to access them from different classes. And what we usually do, I just shown it using the getters and setters generated from here. But usually in each class you can press Ctrl space, and it if you type get, then you also have this. You already have the suggestions to the method to be generated, and you can select what is the method you want to generate. And for example, I want to generate get age, and using this method, I will be able to access age attribute from different class. Basically, what I need to do. Okay, let's just quickly create the constructor to make it more understandable for you. Constructor, I will construct the object. Name, surname, and age. I will construct the object here, the employee here. And surname. So I will construct the object from here. Now the main method, and I will construct the employee. Name. Cool. I can't remember to say it would be 51 or something like that. Okay, and just last thing. Okay, that's really enough. Okay, so now we create the object, and again, since the attributes are private, we cannot access them directly. But to get the name, we can use the getter. Let's remove this, but sorry, that's age. And the same for all the other attributes. We usually do it for all the attributes, but again, in some scenarios, some attributes must be missed. That depends on the scenario. So for all the getters, you have this using Ctrl space, you get the suggestions. Get name, I can just easily generate the getter, then and get surname as well. So now I have the getters, and using them I can access the attribute the same way as just if I directly access it, but using the method. name. Then I can do the same for the surname. So if I execute, you see that it shows me the output. Just paste that. Alright, so that's for the getters. Basically, the idea for the getters is that these are the methods which return as the variables to us, the values of the variables to us. And the second thing is called setters. So as for example, we can have the parameterized constructor and for example have empty constructor. In this case what can I do? And of course, yeah, also if you want to change the values, we will also need the setters. But okay, let's create another object. We'll see. So I can create employee without the parameters because I have such constructor defined here. So if I have such constructor, I can choose which constructor to use. If I pass the parameters, then I will use this constructor. If I don't pass the parameters, then I will use this constructor. And in this case, I can and at the moment I will generate the setter methods. So I will generate the setter methods, and the same as for getters, we can type set, type control space, and we'll see the suggestion for us to generate the setters. So the same for age, the same is for name, and for surname as well. So now we have the getters and the setters for all our private attributes, so we can basically simply work with these variables practically the same way as if we do it with public attributes. Yeah, but in this case we use the methods. So, and what we can do, we can set up, basically I would use setters to set up the values. So in this case, what can we do? Now set name. I can do it page of Bill Gates, but that's just imagine that he is 60 years old. And yeah, right now I can basically print all the values. And before I do it, I will also print the line space. Line separator, and let's see what I have here. I get the same, almost the same result. I mean, from the perspective of entering, we just enter the values, and we get these values. So basically setters are used to assign you to set the values, and getters to get the values. Alright, so that's yeah, maybe one more thing, just small adjustment. For example, what's the advantage? As I said, we can add the validation if age is greater than greater or equals to 0. Then we set up age, otherwise we print out that the age cannot be negative. And that's that on the next. And we don't set up the age here. Something similar can be done for the names. Yeah, for example, we can use the regular expressions if notches, then we remember to use the alphabet. Yeah, set plus, and so we don't have any numbers or any other characters. Just for example, else with only the name must characters, well, not characters but the letters only. So simple, and basically the same for the surname. Okay, so I will check with the current solution. It's fine if we try to set something like this. We'll see that the input will not be allowed. Let's remember that. Oh, so yeah, the age can be negative. Yeah, well, put the line separator here just to separate from correct place. Actually, and yeah, then the age won't be set up. What else? Yeah, the same for name. If we add some digits to the name, then we'll see that the name must contain the letters only. So that's basically the reason. Yeah, one of the reasons why we use private attributes. And getters can be used to control input and output of these getters, of these variables. Okay, let's move on. That's for as an example. Let's, for example, we have these attributes. Then the getters are defined again. To remember, we define them as public to access them from anywhere practically. There's no reason to define them private because there's no sense. It's public. Then if we have getter, then we remember that we must have the returning type. For setters, we don't need to have returning type because if you set up the variable, there's nothing to return from the method. But if you try to get something, you want to get the value of the attribute. So that's why we need to define the type, and we define the method name, which for getters and setters are get or set, and then the attribute name in uppercase always. Even if you we use, I think I mentioned it once, but in Java we usually use a called camel case. So we start the method names start with with the overcase letter, and then in the middle to separate. We use separation of the different words using changing of the case. So we start with lowercase, then to go to the next name we use uppercase, and so on. So for getters and setters, getter set, and then the attribute name starting with uppercase, and we return inside this method. We can have additional logic if there is such need, and at the end we return the value of the variable. Set methods also the same. To initialize the field with the argument or to change the field, it's always the void, as I just mentioned, no returning type, because for setters there's nothing to return. Of course, if you have some exit codes, just like check if value is set, sometimes we also have such setters, like for example, what can we do? Maybe I will comment it out and create it in a little bit different way. So if we if we type something like that, so I can return exit code 0. So maybe I will type it this way, return integer value, 0 means the value is assigned, 1 means the value is not assigned. As an example, we can use it as an exit code. Maybe instead of using system out here, I will use. We don't need. We need return. Sorry. And in this case, I'll just return exit code 1. I'll call it exit code. Sometimes called so in this case we there's no errors, because if we call the method we can skip fetching the returning value, but what we can do here, we can type something like if set h equals 1, then we print out that there are some errors. So if the value returned and then the error issue, error issue occurred. And we can type the reason of the issue. That's also one of the options. And name is no. Why the name is no? That's because I named the name incorrectly, so I will have the name there. But that's as an option. We can have for some setters, that's not by default, but in some cases to clarify if the if the method is executed correctly or not. There are so-called things like exit codes, and if the codes have one value, then there's execution successfully done. If the code is with different value, then there's some error security. That's as an option. Okay, let's have the break now, and after the break we'll continue talking about object-oriented programming. Okay, let's move on. So that's for the setter, and so notification need to set in the method if needed. So that's basically the idea. If you want to see more examples, basically we'll definitely use setters and getters almost always, right? Since now. But if you want to check some other examples when getters and setters are used, you can check the link. Check link here. Presentation here you have. And just right now let's have almost like a summary of types of the variables in class. So we have what are all the possible types of all possible ways how we can declare the variables in the classes. So we talked about non-static instance variables and static variables possible, and also we used local variables. So the definition is that we define the class attributes either per instance or static under the class. So we have a class, we have the brace here, and inside the class we define the variables. If we have local variables, then the local variables are used inside the methods, or they can be declared directly inside the methods or using the importing parameter. So that's where we can declare them. The idea for the local variable is that they are just used when we call the method, the variable is created, then this variable is used. After the method execution of the method is finished, basically the variable will not be available anymore, and in fact the value will be lost. So we create the method, we call the method, we go inside the method, we have the variables, then we go outside the method, and the variables are not available anymore. They're just basically they're just like destroyed. So they are not available anymore. So we'll talk about the scope of the variable definitions. So these are the summary. This is the summary of local variable inside the method, and the variable only inside the method, and basically the scope of the life of the variable is when we call the method and when we go outside the method. Instance variables, they live together with the objects. So object is created, the variables are available. They may be initialized or not, depends on the logic, but basically the variables are the part of the objects, and each object has the attributes of the instance variables. And the static variables are always available during the execution of the program. So we execute the program, these variables, static variables will always be there, they will be available. It depends on the logic, of course. You can hide them and declare them as static, then they won't be available from outside the class, but basically the scope of their living is basically execution of the program. And the value is shared for all class objects as well, so that's what I just said, visible for all the objects, for basically, and not only objects of the class, but for basically all the program we have. So you can see the difference of declaration. So we can have static variable, part of the class. Then we can have instance variable, part of the object, individual object, and we have local variables which are available only inside the methods. And yeah, that was introduction for so-called variable visibility. As I just mentioned, we can declare the variables in different places, and based on the place where the variable is declared. It is in some cases, from some places it is not possible to access them. It depends on the scope where the variable is declared. And it is defined by carve braces. By a variable scope inside the call fragment. So this is declared, starting from declaration point. And so let's talk about it. Basically, it is important to understand where your variable is available. So basically, the scope of the definition is there's comments. In this case, that's the method. We declare the variable, so the variable will be available inside the method, everywhere. If we have some cycles inside everywhere in the method, and this variable will be available. We can access it, we can change it, we can do whatever we want with this variable inside the method. So and in this case, the scope starts here, here, because here we declare it, and the scope is ending here. So after that, we want no other place we'll be able to access this attribute, this variable. If we want to access it from somewhere here, it is not accessible anymore. Then if we talk about the class attributes, in this case that's most about the instance attributes. In this case, the scope starts at the declaration, the same as for all the variables. So at the place they're declared, only starting there, they will be available. And the scope is ending at the end of the class. So for all the basically the braces start here, and the ending brace is here. So for this section, this variable will be available basically inside this section. All the methods, in all the cycles, basically everywhere. So even more, even if we have some inner blocks of code, it doesn't matter how deep these blocks are, everywhere the variable will be available. If it is declared in class, and the opposite way it does not work. If you have, maybe let's have a short example. This is called so if we have a cycle, as you remember, let's declare something like that. Then if we declare the variable here, then the variable will not be available outside the block, because again we can go just from top to down, but not from down to top. So in this case it is not possible. But if we declare it if we declare it step. First, if we declare the variable here, then we can access it inside the cycle. It's possible. Yeah, the same as for all the walks. If we go from top to down, yeah, it is possible. If we go from down to top, it is not possible to access. Same as for the class, for the attributes. Yeah, so if we have something like another method, so from here, if we declare the variable right here, what would be an integer, then we cannot access it, from different methods. That is not possible. One method 2, cannot access it as well. But if we declare it inside the class, we can use it. So basically, yeah, from top to down, we can do it, but not from down top. Yeah, basically, you can understand it when you just look at the braces. Yeah, where the braces start. Where's the start of the block? So inside, what is declared inside, everything will be available inside the scope. So that's the topic about accessing. And right now, yeah, as I promised, we will shortly talk about this keyword, basically what it is. Using this, we can basically specify the instance. The same as for all the objects, this is also the object. So as you remember, we used it. Okay, maybe I will create a new method and a new class, and we'll see how it works. Okay, I will create the class. Okay, now let's see this class website, for example. And so we have a website, we can have multiple websites, and we can consider them as the objects. So let's declare the attributes. Declare here as URL. And also maybe a host name as the string. Import or something like that. Oh no, host name. Maybe let me just something like import. So we have a website, we have some attributes to the website, of the website. Let's add more. Startup, maybe a creation year. So now let's create letters and sectors. Hostname set hostname. And then we get support get URL set URL. Yeah, so right now let's define the object. Okay, and also one more method I want to create is just show all the attributes. Show attributes. I will print out. And the URL is this. And I will print the host name. Port. And website is created. And here. So right now we can use the subject. I will create the website object here. I will set it will be created this here. Set host name. Something random. Name. It's kind of improvise digital web hosting. And then support. Number. Something like that. Then we can set URL w set.com. And so now we can print show the attributes. And so normally, and that's as usual, we have all these attributes. We can use them, we can set them. But what about this keyword? Basically, this is, as I said, this is also the object, but it refers to the object inside the object. So maybe as an example, I will just to show you, that it is the object. So I will. What I will do, I will basically create the method, and the method will return the website object, and I will call it get me, and I will return this. So as you notice, this syntax is correct because this is the website. So I'm currently inside website class, and that's why if I return this will return the current object. So basically, return the current yeah, and just to check it, we can simply call it not from here, but from here. So if I keep showing that attributes this way, if I this way, object. So I create new variable here. And from here I call the getMe, which returns the object. So, and if I call the methods show attributes from here, you'll see that the result will be the same. Result will be the same. This, because returned object is same as, and even more, we can check it using a comparison operator. So I can quickly check if they have the same reference, and we'll see that they will have the same reference. Yeah, so that's true. So basically, I will not comment it out, but I'll just the object have the same reference. So it basically means that, that this equals, so from the perspective of our program, this equals the object we created on line 7. So right here we created this object, and this is basically the same object in the main method. Basically, this is the same object, and that's why we can use it just as the object. Yeah. So we use the objects this way. Yeah, we create them and we use them. They refer to different class. And if we are inside the class, we can use these objects using this keyword. Yeah. So basically, this is the same access for the objects, but just from inside the class. Yeah. So, and as an example, there's how to get declare to access the variables, attributes of the objects we are currently in. So for this purpose, we can use this and access the attributes of the current object. And the last thing for today, for this presentation for today, is so-called dot operator. Yeah, we usually use it. We use it from many different places. What basically it means? It is so-called the referencing operator, which basically dereferencizes the reference variable. Using this, we can dereference it and access the methods or the attributes of the object. Yes, so for example, the computer, there's computer C1, and we need to specify computer, which one we want to access, and then using dot operator, we dereference it, and we access the method or or the attribute. So basically, from the referencing, it basically means that we go inside the referencing. If you go a little bit back to the definition, right here. So as you remember, we have the reference and we have the variable. So using dot operator, we actually we pass this step and we access the members which are defined members of the memory. If they're the attributes, then we access them. If they're the methods, then we access the logic which are assigned to these objects, and we can use them. So basically, here. No. So basically, that's what we do. Yeah, that's for the reference variables. For the remember that for primitive types, like for example, for decimals, dots are using to separate decimal places. That's why there's the difference between reference variables and instance variables, or reference variables and primitive variables. For reference variables, always dots are used to access the attributes or the methods of these objects. And yeah, multiple level calling is possible. So if we use dot, we can access method or the attribute. Like in this case, we access. So we have system class. I'll show it right here. So we have system class. That's the class. Then we have static attribute out. So that's print string. So that's the attribute. We access it, and after we access the attribute, after that we can access the public members of this attribute. The same way as we access the class. If we have another class or object, we can access it using dot, and then we call the methods we can call the methods, so we can access another attribute, then access another attribute, and so the same way for the methods. If we have the returning type of the method, then it means that methods return something, and then if there's something returned, which is also the reference variable, then we can access this reference variable and also call the method or access another attribute. Okay, so that's practically it for this presentation. Next time, if you have any questions, you can prepare it for the next session as well. We'll have time to answering questions. And right now, let's move on to the practical assignment. So, but again, if you have any questions, you can every moment you can ask. Every moment. So let's move on to the practical assignments. And the first assignment would be to check the file. I already shared the file with you, so you can open it. I will move it to my second monitor, and let's do the practical task. So the assignment is write the program where actions with officers, policemen are provided. As you can see in this picture, this is so-called UML diagram, which basically describes the properties of the class. So we we can implement the logic and create the class. Okay, so the class name is officer. So let's do it. Let's create the class officer as it is shown in the picture. So we have class officer, then we have the attributes. The attribute is name. And there's the attribute surname, which is string as well. Then we have officer ID. We have another string. I'll type it here. Working district. And crime solved. Oh, that's integer. Sorry. That's integer. Okay. And there are the methods. No argument constructor. So this means this one. Then argument constructor, which will be the constructor with all the arguments. I will type them this way. String serving. String working strict. And two integers. Then we have get and set functions, getters and setters. I'll generate them this way. We can go, as I mentioned, we can go to the class file, and go to source and go to generate getters and setters. I will select all of them and I'll press generate, and then all the getters and setters will be generated. Alright, so the next one is toString. I will also define it. toString. Yeah, you will see that some methods may be pointed as override. That basically means that these methods are inherited from superclasses. Yeah, we'll talk about inheritance a little bit later, but just for you to know, to point that this basically it changes almost nothing. If we delete it, that will be considered okay. That one that is not considered as the error, but normally the effect of override comment is basically not. In this case, for us, it means practically nothing. But that basically, yeah, it just shows us that this method is overridden. But the effect for the execution, basically there won't be any effect here, any effects here. Okay, so we define the method toString, and calculate level, so which returns us which will calculate us the level. So now we declared all the methods as discussed, as it is mentioned in the schema under the officer, and now we can implement the tasks mentioned here. So first of all, there is mentioned toString is the method where information about the object values are returned as string value. yeah, this is basically what usually toString methods do. In our case, we can implement it as we want. So what I will do, I will print all the attributes of this, or not print. I will I will return the attributes in the following way. So we have name, name is stated here, and then I will add line separator. Then I will add, I will add surname, then I will add the line separator. So this will basically be the string where each text, name, surname, will be positioned at different lines. So that's why I use line separator to just go to the next line. We have officer ID. Then we have okay, and then I will use line separator. Then we have working district, space, district, and then I will add line separator. Crime solved, that will be the last parameter. Crime solved. Alright, so now I returned basically all the description of the object. Yeah, currently. We'll see how this method works to string. But it works in very interesting way. I will show you. But right now, let's implement all the other methods. Calculate the level is the method where officer level is calculated. So let's calculate it. So as I mentioned, if the crime solved value is less than 20, then the level is 1. If larger than 20, so equals larger or equals than 20, and less than 40, then the level is 2. And the last case is and the last one is if larger than 14, then we return 3. We don't need to add the condition because this will basically mean that this condition will be here. Because if it's full, because then this is integer value, it can be from minus one value to plus another big value, but not and yeah, that's why if we have negative value, we won't have negative value, but basically all the cases are will be covered here for all the integer values. That's why we don't need the if condition here. Okay, so that's about calculated level. The method is implemented, and we can use main method. Yeah, one more thing, because you remember, if we don't have main method, we cannot execute the class, because we have nothing to execute. Only main method can be executed. Okay, so and from main method we can we will create three officers. So the officer. Okay, it does not mention what are the attributes we need to provide to the officers, but okay, then I will provide them. The officer. So they mentioned we have three officers, so we need to create them, and yeah, let's add some information about them. So one I will set crime solved to 434, and then I will also set name to officer 1. So 1 will set surname. Something like that. So I will set his ID, some number. I will set district. Brooklyn, something like that. Okay, so maybe I will just print for the first officer. But okay, maybe let's quickly create for other officers as well. So 2 third officer. Change something. So the first one, same as it is. District, let me be. Okay, I'll just keep as Brooklyn. And I'll change some ID, change the IDs just to make it different. Okay, and it says that we need to print the information about them. So what we can do, we can basically print the information about them. So I will take the first officer, and then I will print the string. String of the first officer. So basically, yeah, that's what I said. Let me do the same for other objects, for other officers as well. And then I will this point. So as you can see here, we just print the object. Yeah, we don't print the string. We don't print the string. We don't print any primitive type. We just print the object. And basically, that's the syntax of Java. We can print the objects, and basically what will be printed, we can see it now. We'll print the stuff defined in I think I will add one separator just to distinguish them, distinguish the officers. System and separator here and here as well. Oh no, here definitely. That's the last one. Yeah, so right now we can see that basically what is printed, maybe can you understand from where it is printed? The question to you. Do you understand from which place this content is received, is fetched? Can you get any guesses from where it comes? It actually comes from toString method. So basically for every, and that's also a topic about the objects, about the classes, in every class, for any object, there is the method toString. There's the method toString, which actually by default it prints the reference. Maybe I will point to comment here. By default, string prints the address to the memory, to the reference. The address of the reference. The address of the reference by default. If we override it, it prints. If we override it, it prints what we provide in the method, what we return from the method. And in this case, yeah, if we pass the object to the print line, then it returns it prints the value received fetched from the returned from string method. And so if we use the objects as the string, then the method toString will be called. So that's the option. Yeah, as we remember, we used method not here, sorry, here, but here. For the we used method display attributes, where we just printed all the attributes of the objects to represent and to describe the main properties of the method, basically to convert. In some case we can call it, from some point of view, we can call it as converting to string. So just to describe the object as the text, we can use toString method. Yeah, that's the purpose. Okay, we will continue with this task after the break. Okay, let's continue. And yeah, as it was asked by Jart, to show this part again. So yeah, that was mentioned in the task to create constructors. Basically, there is no mentioning about their implementation of this method, but yeah, we can implement this constructor by, as we already know, just to passing all the parameters to the object. We assign all the values to the object attributes. So equals prime salt. And so prime salt, what else do we have? The offset ID. This working district equals working district. Okay, that's the part. These are the constructors. So we create the object. We have two options: construct without the parameters or construct with the parameters. Okay, so that's as it states in the part B. So part A is done. We created 3 officers as object and printed the information about them. Alright, so next one is we need to create a new array with the type officer. So let's create the array. Officer and the district 99. Okay. District 99. Type officer and put all created objects of the officers in it. Okay. Sorry, this way. Okay, so in this case, yeah, we can see that the syntax is basically the syntax is the same as for all the arrays that we previously had. Remember that to create new array, we need to call new. That's because we create new array, new object, okay, new array. Then we provide the type, and then we provide in the square brackets we provide the number of elements we have inside the array. And so in this case we don't create the officer as the object, we just create the array where we can place our officers, our objects. So just a small comment. Officer, yeah, array is created here. No officer objects. Just to distinguish, we don't create the officer object here. Alright, so we created the array, and then we can put all our officers there. Okay, so here we have, so here we have this part, So that's fine. This point is done. Let's go to the next point. Find out how many officers are with level 1 in District 99. Okay, so let's check it. We can use for each. So this officer, and so for the objects, the same way as for all the other types, that the loops are the same. We define the type, as you remember, for integers, for all the primitives, and for strings. We define the type, then we define the variable, and then we place the array. So yeah, here I will use the counter. Count level 1. Start with 0. And then we add the counter. We increment the counter if the level of the current officer. There was the method calculate level. Calculate level is 1. If it is 1, then we increment by 1. And again, we can print out how many officers have level 1. Who have level 1. So let's see how it works. There are no officers who have a level 1. That's because all of them have more than 20 plants. So let me just quickly adjust the values here. And values here. Then we'll see that there should be 2 officers who have level 1. 1 and 2. Alright, so this part is done, and let's go to the next one. Find out how many officers are with the level which is larger than 1. Okay, we can do the same. We can use the same loop. Greater than 1. Use if else, and count level greater than 1. We can increment the same way. And I will also print it out. Basically, we can we can use this solution, or that solution is correct because we just did this. Okay, that's correct. And so there are 2 officers who have level 1, and there are 1 officer who have level greater than 1. But what else? How else we can do it? The more efficient solution would be if we skip all these steps. We can just what we can do? We can just type 3 minus count level. That would be the same. sometimes, yeah, we need to use the brackets. Yeah, please use the brackets, otherwise the program will not understand that you want to use mathematical operation here. So this approach. Yeah, that's obviously if we have count level 1 number of officers who have level 1, that's obviously then yeah, maybe to be more precise, even if we increment and the number of officers we can use point variable. Yeah, if we just subtract the count level 1, then we'll obviously get remaining part of the officers, and this will be the correct answer for us. So yeah, you can see that the result is the same. Okay, so let's move on to the part E. So part E is done. Find out if there is any officer with the name John. So basically, yeah, we can check it using again another loop. I will copy this loop. Yeah, first of all, I will point if. Oops, sorry, that's the next line. I will create the flag, which points me if there is the officer with the name John or not. There is John by default false, or maybe let's call it that John is found. Is found. By default John is not found. So, but let's search for John, and if officer that name, again, since this is string, please remember to use equals, and we can check John. If this is true, then John is found, and we can actually finish our for cycle. Since John is found, we can, as we go out of the cycle of the loop, we can stop the loop. And so if then we can print the corresponding result. Yeah, we can do it the following way. John is found. If true, then John is found. Else, John is not found. Yeah, we can use. We can skip using if else, because this basically, as you remember, means condition true false, condition true false, value if true, and value if false. a small reminder how this syntax works. And let's check. Yeah, John is found. So we have John. All right. So that's for these points. And as you can see, we have additional point, which we can do right now. Why not? Using scanner class, ask for input of all officer values in the console and create new officer in the system. Okay, we can do it. Just to establish the logic, I will print one separator. And okay, let's use scanner. Again, I will copy paste the logic we have here. And yeah, it says that we need to create the officer. So enter name. Then oh, sorry. This one. Then we can, yeah, first of all we can start with creating the object. Officer, and we can create the object. And yeah, so now we ask user to enter the name. So, and we can directly set it to our object. So to do it, we can call scanner and we can call the method next line. As you remember. So the same is, so we set the name, and we provide the value, and the value will be returned from the method next line, which is the value we enter from the console. Same way we can do for surname. And here I will set surname. Alright, so then there's officer ID. Enter officer ID. This officer ID. And here I have integer, that's why I need to use parse integer method, and only after that I will use next line. So here I get the value input from the console, I put it to the method parse integer, so and this method will return as integer from the string we provided in console, and this will pass this value to set officer setter, which will set the value to our method. And the next one is working district. And so this is string, I will set it the same way as we set the name and the serving. Next one, And then we have we have the last one, enter crimes solved. So here then we have integer, set crime solved, so I will need to parse integer again. And this looks fine. And what we need to do, we need to add it to our array. Oh, actually we cannot add it to our array because our array has three positions, so that's why we need to create new array. But okay, what else we can do? We can create new array. Since it is not mentioned in the task, we can add. Basically, we can do it this way. We will move this logic up. And we will add it to the beginning. I will also print our new officer. I just make it more clear for us. Not officer 4, but new officer. And here I will increment by 1, and I will add another officer. So let's see what we have. Method. So the name would be surname sample.d district 9 so 40. Anti-Trojan is still found. There are two officers. Yeah, there are two officers who have level greater than 1 and two officers who have level 1. And here there's also our officers printed. So that's what we can do from console. Basically, from console we can do it the same way as for the objects. We can do the same way as for all the other variables, but just using the methods we can access the attributes and assign the corresponding values to the attributes. Okay, so this is one assignment. I think I accidentally forgot to include another assignment, so I will do it quickly now. Moment, and I will also share it with you. Moment. Okay, we'll start today, and most likely we'll finish on Monday. So I will just paste the method, paste the task here, and then I will I will share it with you right now. So this will be adjusted, and there is one more assignment here. So in a moment I will share it with you. This one. And there's, you can see there's one more assignment, and we'll do it now. Yeah, this one. So we'll do it. We'll start doing it now. Okay, so it says that we need to copy officer class in new project. Okay, so for this purpose we need to create a new project. Okay, let's maybe I won't create a new project, I'll just create a new package. I'll just create a new package, and I will call the package assignment, call assignment officer. So, okay. And I won't copy the class, I'll just we'll just use it in a different way. Oh no, we need to copy it, okay. This will adjust it. Okay, so that's why. Let's copy it. We'll have different package. So I will. So I just copied, so we have two officer classes in different packages. So, and yeah, it says that I need to delete variable working district and all the code parts related to it. And it is also not said that we need to have main method at the moment. There is no logic. We need to have in the main method. So I will delete it and then write it again later. So, and it says that I need to delete all the related code, which uses working district. So I will do it as well right now. Yeah. So I've done it. Yeah. So this part is done. Then create new class district as it is shown in diagram. Okay. Let's create. Showing diagram, and here it says that we have title string title, then we have city and district ID. Oh, that's integer, sorry. District ID, and officers in the district will be the array. Array officers in the district. Alright. So, and the methods. No argument constructor. In fact, so if it won't be changed, we can skip declaring it. There will be no effect on it. That's why maybe let's skip declaring it, because it will be available. We will not just see it in the code, but it will actually be the same. So there is no sense to declare the empty constructor without any code. And that's why I'll skip declaring it, because actually it will be available, but we won't see it in code. And the effect will be the same. Argument constructor. So for the argument constructor, I will declare the code string title, string city, integer district, and yeah, and we want oh no, actually, let me think. Yeah, we can add officers in district as well. Just parameter. Just try it again. So these two F's, and I will assign the values. Title, city, and there is yeah, the last one is officers in district. So using this constructor I can pass all the values. Okay, so then I have getters and setters. Again, I will go to source, generate getters and setters, and generate for all of them. And then to string, I'll generate the string. Title, this title, then I will add line separator, then I will I will add city, then I will set the line separator, just copy paste it, then I will add title, city, and then district ID. Then to the next one. Line separator. Then city, and the last one. There are officers in the district. Okay, so now we have this to string, which will to which we will convert, the object will be converted, and we pass it, for example, to print out method. Okay, so this is done, and then we can add new officer. New officer, this will be the method public void add officer, new officer. And from here we can add new officer. Basically, in this case, there is one interesting thing. Basically, if we add new officer, we will need to create a new array. Actually, we can do it. Why not? In this case, if we create new array, we can do it this way. Create new officer array. And that would be, there will be more logic if we do it, but okay, we can write more logic. So basically what's the idea is we have the array which stores all the officers into the district. But again, since this is the array, as you know, we cannot change the size of the array. It is not possible. Basically, there are two options we can use. We can skip using arrays, and normally we use collections. And maybe let's use the collection. Let's use the collection, and I will introduce the collection here. So basically, yeah, what we have. The problem. What's the problem? The problem is, as I just said, for arrays we have exact number of elements. We cannot add new elements. We cannot enhance this array, and we cannot reduce the number of the elements as well. In this case, arrays always have fixed number of the elements, and this is the case which is not acceptable if we actually don't know how many elements we have in the array. So I will type the comment. We can, but in this case we need to manually always create new arrays. That's basically not the way how we usually do. Can't change the size. But basically what we can do instead, what's the approach usually used, is so-called collections. Then we can create the array list, and this is basically the list. Inside, yeah, there's also so-called generics, and we'll talk later about what are these generics, how they work. But just for this usage, for this case, we will for the lists, for the collections inside these inequality signs, we provide the type of the collection. So basically we have the collection. Oops, not this officer. Oh no, yeah, officer. That's correct. We provide the type of the elements which are stored in the collection. So in this case, this is collection. We define here, and I will create this variable. So, and we can also initialize it. We need to create new array list. Array list, that's also the object, the class. And we need to create new object. So in this case, it's the object where we can store as many officers as we want. And we'll see how we can use it. Okay, maybe in this case I will again skip, as I wanted once, I will skip using officers in this. So we just allow the options to set officers using this method. And so what we can do in this method, that we simply just use officers in district, and we will add new officer. So that's how the collections, how we can work with the collections. We have the object, then we have the method. And the method is add. It means that we add new element to the collection. New element to the array list. Okay, let's call it array list because that's also part of the collection, part of the collection framework. So yeah. we add list. Yeah, that's how we can do. Also, since we changed the type, we need to generate. Let's generate getter again. Source. Generate, and we have option to generate getter and setter. So it's good. Yeah. Okay. So it is done, and then we have remove officer. Remove officer would be similar with remove officer. We need to provide the officer. Okay, this one, officer. Remove, and there are two options. Since we have array list, this is basically the list where all the elements are indexed. Yeah, we'll discuss the collections a little bit later, but yeah, since we now use them. We now use the array list. We can talk a little bit about them. So we have two options. We have remove. We can remove the index, the element by index. So maybe I will quickly draw to you. So basically, again, the collections are like the arrays, but with dynamic size. Yeah. So then we have the collection. So again, we have the collection. And inside the collection we can put the elements. In the first place, on the second place, and so on. And they are indexed from 1 to n, yeah. From 1 to the length of the array. And yeah, so they are indexed. If we add the first element will be positioned at index 1, index 0. The second element will be positioned at index 2, and so on. And we can access them using get. Officers get. Yeah, we can get by index, element by index. So we provide the index of the list. Then we get the corresponding officer. Same as to remove. We can remove by providing the index. So this will remove, if we call the method remove, we pass the index, and this will remove the officer, which is located at the index we provided and the position we provided from the list. And another option is we can remove using the object, and this will actually remove us the corresponding officer from the list. Yes, so, and the last method we have is calculate average level in district. Let's pause. Calculate average level in district. And yeah, this will return fault. It is not mentioned what the logic will be. We'll see in the task a little bit later. Okay, now we defined all the methods, and we can implement the logic. So as we can see, the variables of some districts from one district will be saved. In this case, relation as the composition will be used. Yeah, you can see the scheme. So this is called composition when we use 1 object inside another object. We defined class officer, and we use this class inside another class as the attribute. That's also possible. Yes, that is called composition. And we combine the classes, and it's again, as you know, we can use strings as the parameters. We usually use strings as the parameters, and that's as you remember, strings also are the objects. So we basically use one class inside another class. We can use attribute of one class, which is actually the object, which is referred to a different class. So we can do it. Why not? Okay, so let's quickly go through some steps, and then we will finish today's session. Add new officer. Oh, okay, it's already done. It's array, but instead of the array, again, I will use array list. Okay, then remove officer. Okay, that's already done for us by us. Remove officer. We removed the officer, then we added the officer. Okay, calculate average well on district. Okay, let's create this method and then we'll finish. Create implement this method and then we'll finish. Where total officers levels will be summarized and divided by the amount of officers in the district. Okay, so here we need to sum all the levels. We'll sum. We'll start with 0. Then we will go through all the officers. And yeah, one option is to use cycle, but we can use so-called iterator. Oh, yeah, that's okay. Maybe let's at the moment not use iterator, because this I need to talk more about iterator, because this I need to talk more about iterators. So that at this point, let's just use let's just use simple for loop. Then we call this officers in district, and yeah, from the collections to get the length, we call the method size. Method size will return the number of the elements in the collection. Okay, we have size, and then we implement I by 1. And as it is stated here, we need to sum all the levels. Okay, that should be float. That's float. And for each officer, I will add the level. By taking each officer, I will get officer's level. Okay, and so I will retrieve the corresponding element from the collection. Again, I can use get. Using get, I will get the corresponding officer. So now I get the officer, and I can calculate level. Calculate in the brackets, and at the end I will return level of all the officers. This is how we can do it. Yeah, that's how we can work with the collections. Yeah, we can use get, we can use add. To add and get elements. To add and get elements. Okay. Okay, so I think for today we can finish. For the next time I will I'll share the home task for the next the Monday after next week. It will be for 18th of January. I will share we will share the file with okay, no, maybe yes, I will share this file with you, but before you start doing it, we will finish this assignment we have now, because some tasks are based on not some tasks, but all the tasks from the assignment are based on the assignment we do now. So on Monday we'll finish this assignment, and then you will be able to do your home task for week after next. So there are 2 assignments similar to what we done today and what we'll do on Monday. You can start working on them. Obviously, if you have any questions, please reach me. And one more thing I would like to on Monday we can have the part of the lesson to questions and answers. So if you have any questions that you want to ask about object-oriented programming or any other questions, please prepare the questions for the next session. You can ask before the session, so I can prepare a little bit and to have a discussion on Monday about the questions. But for today, as usual, I will share all the code with you. And so then, as usual, you can check it on Bitbucket. And yeah, that's it for today. Thank you for your attention. Have a nice weekend, and see you on